Welcome back to these tutorials on AndEngine. We're going to start building Tic-Tac-Toe today, and this video is going to focus on designing the game. So we'll do a brief review of what the game rules are for Tic-Tac-Toe. I hope they're fairly universal. We're going to look at wireframing, so that will control the flow of the program. And then we're going to look at designing a small user interface. So, the basic rules for Tic-Tac-Toe are that it's played on a 3x3 grid. On that 3x3 grid, there are two players, X and O. Players take alternate turns, and each player places their mark on an empty space. When one player has 3 marks in a row, they're the winner, and you start over. This has been scratched out on cave walls since the dawn of time, as far as I know. Probably a lot closer to the Greco-Roman era, though. Anyway, Tic-Tac-Toe, pretty straightforward. But we're going to need a grid, pieces, and a set of game rules. Now, to control the flow and to design the flow, we want to get a basic idea, and that's called a wireframe. The first thing we need is our game board. So as soon as the application opens up, it should show a game board. We're not going to do any fancy splash page, none of that. So the first thing that shows up is our game board. From there, the only input we're going to have is clicking buttons. So in that case, hitting one of these X's. When you hit one of those spots, one of those touch areas, the game is going to ask a question. Did somebody win yet? If there's no winner, you go back to the game board and let the next person play. If there is a winner, we're going to pop up a dialog that says whoever won, and when the dialog is done, we reset the game so that they can keep playing. To create that user interface, the first thing we need is to build a scene. This is an AndEngine scene, not an Android scene. So a scene is basically what you see with your camera. AndEngine is designed to use 3D entities and to model them in realistic, useful scenarios. So the first thing that we need to model these 3D images is the backdrop. Ours is just going to be a square. On top of that square, we're going to draw solid lines. This is an entity class of AndEngine, but in very simple terms, we're drawing lines. The next thing that we add is the first real complex user component. Inside each of the empty spots, we're going to create a touch area. The touch area allows you to register that this area has been touched and to do certain things with that. What's going to happen is that when that's touched, it's going to run a new thread to do some magic. Okay. So we have some important figures that we need to figure out now instead of having to hack through this later on. The AndEngine examples call the scene width and height, camera width, and camera height. So we'll keep that naming convention alive, but basically it's just the size of our board for this example. We're going to declare a couple of basic values that are variable. They don't need to be variable. We could write 3 in here, but the more variables we use, the more functional our our program will be to expand later on. So that if, for example, I wanted to make a 4x4 grid, all I really have to change is this, not this and this and this and this and this, which aren't here yet. Once we have the grid set up, the 3x3 grid that we know is going to be 3x3, we can start assigning x values. All graphics are done on an XY coordinate system, so we have to find out what those coordinates are. To find, for example, this line, the x coordinate of that line, we take the width, divide it by how many grid elements there are, boom, 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 and multiply it by which one. So x0 is over here, and we don't draw a line there. x1 is here, x2 is here. We can do the same thing for y, where we take the height, divide it by how many there are, and multiply it by which line we want. The next step is we're going to try and find that little value there. That's the separation between the edge of the screen and the touch area. We could do this so that our touch areas are exactly a third of the screen, but then you have the issue where you might have conflicts in touching, where things tiny overlap or just a finger is hitting the wrong spot. Because of the way that we're going to do this, it's best for us to just have a slight buffer, and we have to determine what that buffer is going to be. And it should be calculated. It should not be just arbitrarily assigned. So to calculate that, we start by finding the midpoint of each of these touch areas so that they're centered. The midpoint is 1/6. If this is a third, this is a sixth. To calculate that, we take the camera width, divide it by how many grid elements there are, and divide that by 2. So halfway between there and there. We also have to find the halfway point inside this box. So that is the width of the box divided by 2. By using these three numbers, where we start with the element on the left, add the midpoint of the touch screen, subtract the width of the touch element, half the width of the touch element, what's left over is going to be the x coordinate for where we want to draw our element. So these are all important figures to figure out as early as possible, especially when you're working in a large group. If you figure them out early, then there's consistency. Everyone knows what it is. Instead of having one person solve the problem this way, and another person solve the problem this way, and a third person just put in static values. You want to make sure that all of your values that are going to be useful have consistent names and consistent values determined way ahead of any actual programming. Alright, so using these values, we're going to be able to draw lines on our scene and text areas within our elements. You'll notice, for those of you who are bright and paying attention, that touch width is not declared. In our example, we're going to be using sprites, animated sprites. So the touch width is going to be the size of our sprite. In our case, it's going to be 128 pixels, and that's a static width. We can worry about responsive design much later down the road. Alright, so in this video we reviewed the rules for Tic-Tac-Toe. We developed a program flow wireframe to control and understand where things were going to happen, and then we designed a user interface. In the next three parts, we're going to build the data model for Tic-Tac-Toe. We're going to build the user interface for Tic-Tac-Toe and then tie those two together. It's important that we figure out the data first before we get into the user interface so that we have a clear grasp on what the data is actually modeling. All right. Thanks for your time and have a good day.